So it's on already, right?
Okay.
So really good afternoon.
Good afternoon.
This is my good old friend and colleagues, Patrick
Hello.
Fong. He's from he's the MD of Singapore Green Engineer Private Limited, and I'm really privileged to have him to share with you guys really on the perspective of energy, and also how energy audit is being conducted and what are the landscape in energy. So basically, I just give a very quick introduction about him. He's one of the BCA so-called Green Ambassador, and also the awards from SGBC, being Green Engineer of the Year in 2014, right?
Yeah.
And of course, he has more than 30 over years really in the energy. That's why I really have the privilege of inviting him to have an exclusive interview with you. And also in terms of credential, I think he's a PE, professional engineer, and of course he's an energy auditor also. And also he does lecturing in BCA in doing the Green Mark Professional for FM. So really delighted to have him here. So the rest I would like him to share. First of all, maybe he can share more about your company, then perhaps a little bit about yourself and enhancement. Then after that, we're going to the other project in energy. Yeah, maybe Patrick can take over.
Okay, thank you, Derek, for giving a very nice introduction. And I'm equally, of course, privileged, of course, to be invited to be able to speak to your students. And of course, in this session, I hope to share my experiences with all of you. Singapore Green Engineers actually is one of the leading energy services company in Singapore. We are accredited by the National Environmental Agency as an energy services company, ASCO, and we are also accredited by the Singapore Green Building Council as an energy performance contractor. So the company was founded by me in 2010, and of course, as Derek mentioned, we are specialists, of course, in carrying out energy audits, Green Mark consultancy. But one of the mainstay of our business is energy performance contracting, meaning we provide funded and non-funded solutions to energy performance contract, which I'll elaborate a little bit subsequently later on. And we also do real-time monitoring as well as data analytics, so that the building owners, after you have installed the plant, can actually do post-optimization to further save energy as well as to improve performance of the plant.
Okay, good. I think that's give a good introduction of who Patrick is. By the way, we are located right now in the MCSC office of
Golden Mile Tower.
Golden Mile
It's
Tower.
at Beach Road. This is about a 40-year-old building which we have done an energy performance contract, which I'll elaborate a little bit. But before I forget, actually our track record, of course, will be, IMM, for example, in Jurong East, we actually retrofitted a plant. It was about $5 million. We saved them about 30% of the chiller plant energy cost. We did the Tampines Mall. We did Suntec City. That was a more of an optimization project.
Tower 1, Tower 2,
all the 5 towers.
All the 5 towers in Suntec City.
And the common retail mall, as well as the other one was the
hotel side?
No.
The conference side.
Yeah, the conference. Okay, we also recently did the Chai Chee complex, comprising of 5 of the buildings. The one at quite near Bedok Mall. Okay. So replaced the entire chilled water plant. And recent projects include the Upper Serangoon Shopping Centre, which was combined 2 of the chiller plants into a single plant. And currently, we are also doing many of the hotel projects within the equity. Stable, yeah.
That's really impressive. So basically, we will zoom down to what actually he so-called Patrick is involved in. I think Patrick has done various projects and many projects, been in the government sector as well as in the private sector. There's an element called GSP. Later, Patrick will share what's GSP for the government side, basically. And then there's another, they call it EPC for the private side in terms of how they finance the project, basically. So he has done many of these. So maybe I would like him to share, maybe first on what's GSP and what is EPC, and how the model work and
sure. Yeah, a lot of these kind of acronyms that really used in this industry, and people who are ESCOs in this industry will understand what it is. So GESP stands for actually Guaranteed Energy Savings Performance Contracting Project. This is used by the government agencies for public buildings. So when they call a tender, those who are qualified meeting certain grades will tender for the project. And normally it comes in two parts. The first part is to carry out an energy audit of the building.
Oh, so
and to
audit first.
and then you compile and come up with what is the projected savings, whether it is viable to proceed or not.
Alright.
So if the project, for example, you find that the savings is fall short of what is the expectation, then they may abort the project. And then the government will pay half the consultancy fee that you have actually tendered. Only half, yes. But in the end, that the project is accepted, of course, they will pay you this part of the consultancy fee, and of course, you carry on with the project that you attended. That's the meaty part of it, which is to retrofit, for example, the chilled water plant. And that one, of course, once you have completed the project, you must meet certain performance. The performance for chilled water plant is normally measured in terms of the COP, the coefficient of performance, or the what you call the kilowatt per ton.
So COP higher better or lower better?
COP higher the better.
So efficiency.
And kilowatt per ton, of course, the lower better. So it's the inverse. So actually, kilowatt per ton is actually 3.52 divided by COP. This is the formula. So if somebody give you what is a kilowatt per ton if the COP is 6, then your kilowatt per ton is 3.52 divided by 6. So it works out to about
currently
6.
What's the good efficiency?
The good efficiency expectation for a plant of, let's say, above 500 tons, you should be at least better than 0.6 kilowatt per ton for the whole plant. This is what is very good efficiency, but generally 0.65 it's easily achievable for existing buildings like this. For example, this building is a 40-year-old building. So we expect them to do better than 0.6 kilowatt per ton. It may be a bit of a challenging. It's challenge because there's a lot of constraints in terms of piping. You know, you have a nice plant room. We have lots of space, and you can have pipes with a minimum, restriction. You can have long length, less bends. Of course, you have less of the pressure head. Obviously, you have a better performance. But and you have site constraints, and the plants are old, so it's difficult to get the very top range of better than 0.6. Generally, 0.6, 0.7 is achievable with existing building.
Good.
Correct.
Okay. So maybe maybe you can share a little bit about some of your experience in the GSP. I know that you've done quite a few.
In fact, GSP with my previous company, before I set up this Singapore Green Engines Private Limited, I was with Suntec Chesterton.
Oh, Suntec.
Yeah, we actually did the first two pilot projects. First one was the MOM at the Havelock.
MOM Havelock, the
old building, the old MOM Havelock, yeah.
Ministry of Manpower.
Ministry of Manpower. That was our first pilot project for GSP. So that one, of course, you have after you have completed the whole installation, you still have to do 5 years of post comprehensive maintenance.
Oh, so the contract is a 5 years
Include
period?
5 years. After the DLP, you have to give 5 years of comprehensive maintenance contract because you want to make sure that you perform over the next 5 years. And it's all priced into tender.
So what you...
We retrofitted all the old chiller plants, but that was a very challenging project because they had a very old chiller plant, which wasn't performing because the supply temperature was about, I think, about 15 degrees.
Wow,
return was about 20 something. Wow. And then there were a lot of split units. They used a lot of those single split units for all the meeting rooms. And we had to provide a new chiller plant that take into account what would be the air conditioning required for those like ad hoc requirement, off-office hours. So the challenge was to actually redesign and reconfigure the new plant.
So basically you remove the old chiller.
Remove old chiller, remove the split units,
and put in
a new chiller plant, put in new fan coil units, redesign the plant, and to make sure that it can actually cater for off-hour operation and peak hour operation.
The building's still operating during that time?
That's right. So you got to schedule in such a way that the downtime will be minimum without affecting the operations of the building. It's a live building.
Yeah. So what was the outcome after changing?
After changing, initially if you talk about the kilowatt per ton is much higher than 1.3 kilowatt per ton.
1.3?
Because you combine with the split units.
Okay.
After retrofitting, the performance was much better than about 0.68 kilowatt.
Wow, that's quite a big substantial saving.
Yes. Subsequently, in fact, they further optimized and the building became a platinum.
Oh, they
started with gold and now it's a platinum. One of the few existing buildings in Singapore to be platinum.
Okay. I think this is the first few GSP.
This is one of the first GSP contract. It was a pilot one, and then subsequently, of course, the government has got many
Yeah,
for many
you also
public
done
buildings.
a few.
Correct, correct.
Okay, that's good.
So other than that, of course, we do a lot of EPCs. So
Oh yeah, what's EPC?
the next one I'll share with you is the energy performance contract, basically.
Okay.
EPC. It's a design and build, sometimes funded, but for government, GSP is not funded because government has the money. But for private MCST like this one, these are management operating strata title. In other words, there are many, many owners to this building. Okay? So it is an MCST, and the executive committee is actually called management council, which runs the day-to-day of the building. Everybody contributes a management sinking fund, just like condominium. It's like condominium. So this is the MCST. So for this MCST, that plant, this building is about 40 years. Let me start with this building, the Golden Mile Tower.
Right.
To give an example.
So Golden Mile Tower is under not GSP, right?
No, it's under EPC.
EPC. So GSP is for the government.
Government.
And ESP
private.
Private. Okay.
Yes. So for this private initiative is, of course, they invited us to that's the first step to do an energy audit to find how bad is the performance of the plant. So of course, to do an energy audit, we look at chill water plant because we are talking about chill water plant. Right. What you need to do is we monitor the performance over, in fact, a 2-week period. So you do usually a 1 week what we do, but you do an audit over a 2-week period.
So it means you put instrument there to.
Yes, we put in temperature sensors, okay, at the chill water supply, chill water return headers. We put in ultrasonic flow meters. Ultrasonic because we can actually just cut the pipe insulation and then just hang it onto the pipe. Rather than if you want to put a magnetic flow, inline flow, maybe you got to cut the pipes. So we put in ultrasonic flow meter. The accuracy is still within plus minus 0.5%, so it's acceptable. At the same time, we actually take the power consumption, the kilowatt power meter, so that we can derive the kilowatt per ton on a very dynamic basis. We take a minute measurement over a 1 to 2 week period. Right. So from there, we can establish what is its load profile. The whole week, for example, from Monday to Fridays, what time the chiller cuts in, what time it cuts off, and then at night time, what are the night loads. So from there, we can size the chiller system to take care of the peak day and the night load. Right. But in Singapore, we are quite lucky in that our temperature, our climate doesn't change so much of the weather, so it's quite safe, within 5%. But of course, if you go to a temperate climate, then you got to be careful. They got winter, they got summer, they got spring, autumn.
So when you do the audit, you are saying that you need power, you need the temperature, you need flow. Maybe you can elaborate how to get the efficiency.
Okay, you see, in order to calculate the heat load, it's a fundamental equation in calorimetry. The power Q is defined as M times S times delta T. Where M, of course, is rho V dot, which is what they call what's the mass flow rate of the water. Right. Okay, that one is measured in kilogram per second or whatever. Then S, of course, will be the specific capacity of the water, which is 4.2 kilojoule per kilogram degree Kelvin. And then, of course, delta T is the temperature of the return of the chill water, return temperature minus the supply chill water temperature. Right. So from there, you will get what you call the load. We call it kilowatt or the tonnage.
So you get the tonnage
you
first.
Get tonnage already.
Okay.
And concurrently, you measure the power. The power, of course, you measure from the power meter. Sometimes you have power meter that measures the kilowatt. Otherwise, you will measure the current, I. You measure the voltage, and then measure the power factor. So, of course, a kilowatt is, I think for those you know, for 3-phase, is √3 VL I line cosine phi. So that will give you the power. So that power divided by the tonnage will give you the kilowatt per ton. That's the kilo per ton. So you can establish from the audit, the kilowatt per ton, for example, is 1.2. Now, if I go to resize the plant and configure in such a way that I got to put in new chillers, new pumps, chill water pump, condenser water pump, and cooling tower, and if I get a kilowatt per ton of say 0.65, that means theoretically I can have a saving of. So now I mentioned 1.2, right? 1.3. So 1.3 minus 0.65 is 0.65, So I save 50%. Yeah. So this amount multiplied by the number of hours of operation, multiplied by the electricity tariff rate and all that, will give me the energy savings. That's how we estimate the saving. But of course, in engineering, there's always a factor of safety, error of margin and all that. So a very key challenge is, of course, is the instrumentation. If your instrumentation, when we do the audit, is not properly calibrated or has a big deviation, then of course your estimation will all be wrong. And then when you give a guarantee performance to your client, then you will lose money. So in this energy performance contract for this MCST 677 Godama Tower, the client didn't come out a cent.
Oh, they
because they
didn't come
want
out a cent.
100% funding. Yeah.
So where the money come from?
So, and they say that I want only to sign one contract with us. They don't want
Okay.
to sign too many contracts with banks, because you see, MCST, the executive council, most of the council members are owners, they have their own businesses.
Right.
So they come here as volunteers. So the moment you go to the bank to borrow, sometimes you say, can you guarantee? All of them say, no, I'm only a volunteer. So I said, am I to ease your pain and burden? We will come forward and upfront the cost of implementation.
Oh, so your company
My company will borrow from the bank.
borrow from the bank?
Yeah.
Okay.
And this project actually cost about 2.2 million.
2.2 million.
2.2 million is the total implementation cost.
This is only for the chiller or
Chiller
other
plant.
chiller plant.
A whole chiller plant. Remove the old one, put in a new one, put in all the permanent instrumentation, including my fee, my profit,
Consultancy.
everything inside. 2.2 million. So this 2.2 million is called the implementation cost, the total cost of the project, which we upfront 100%.
I see.
So the client only signed a contract with us, SG, and says that, okay, that's your contract sum.
I see.
Then how to repay back? Yeah, so from there, as I mentioned earlier, we have to compute the savings. We have projected the savings to be about $30,000 per month.
Wow, that's quite
Okay,
a
yeah.
big.
So the payback will be about 8.4 years.
8.4 years.
Yeah,
Okay.
from the day of testing and commissioning.
Okay.
So that $30,000. Sorry, I made a mistake. It was about 21,000. That was
21.
my estimation.
Okay.
Yeah, but the actual was 30,000.
Oh, okay. So you achieve higher.
I achieved higher.
Oh,
Yeah,
that's good. So
because
your
we
payback
were very
faster.
conservative. We will make
Right.
sure that hey, you better save. So the 8.4 years is called the guaranteed payback period, meaning what happens? If by 8.4 years I couldn't earn back my 2.2 million plus the interest charge,
Right.
then the whole system and equipment will be transferred to the client, and I cannot collect any further.
So after 8 years,
8.4 years.
8.8 over
Yeah.
years,
The
you-
whole system will be handed to the client.
Okay.
That means they get a new plant, they continue using it, but I get no more money because I
Okay.
make a mistake.
Right. So now you achieve a little bit higher.
Yeah.
So,
So we pay this plant actually pay back in about 5.5 years instead of 8.4 years.
so now with that 30, you
So what happened is we are always fair to the client in the contract. So when we actually collected at 5.5 years, we actually transferred the whole plant to them.
Oh, so as long as you hit the amount that agree,
That's it.
that's it.
Yeah.
Oh,
Then we
okay.
hand it over to them. So to the client is a performance contract. Yeah. They are safeguarded because if it's safe faster, they get the plant earlier, they get the
I
money.
see. So there's more flexible.
Yeah.
And also,
If you don't get it, then 8.4 years, that's it. Of course, they take longer to save the money.
I see. So it's good for you so that you finish faster, you achieve,
Yes.
you get the money, and
Correct.
he get the savings subsequently.
Correct.
Okay.
That's why we also have what they call it remote monitoring. So that the moment the plant is commissioned, we actually have using the Internet of Things. We are able to monitor on our screen on handphone what is the dynamic performance of the plant.
I see.
So that that there's always this saying, if you can't measure, you can't control.
Sure.
So we make sure that we can have the performance. For example, if it's target to be 0.65 kilo per ton, now what happens is along the way, it shows 0.75 kilo per ton,
Then
which
how-
means I'm not going to get savings.
Yeah.
So I have to take immediate action.
Oh,
Like
so
those people who have gone through the army, we call IA, immediate action. The immediate action means I got to zoom in and find out
Why?
0.75.
I see.
Sometimes it could be the chillers, because the chillers sometimes it's not cutting in or cutting out
The
for the right
sequencing is
purpose. The
not- yeah.
sequencing is not there, and sometimes the flow is insufficient because some of them have minimum flow like 60%. So if it's insufficient, it will cause high pressure, it cause tripping, and then sometimes when the cooling towers are dirty, then you cannot get the performance.
Right.
So that is where once we zoom into that subsystem, we can then activate the contractors at site to rectify so that your performance will not be affected.
I see. So you were saying remote monitoring. So remote monitoring means in your back end you can see.
We can
the-
see. We
Oh,
also have thresholds. If it exceeds certain amount of exceed like 0.7 kilo per ton, we will be paged, we'll be alarmed, we'll be informed, and straight away we can take remedial action. So this is like a negative feedback system, so that
So it's very
anything
good.
happen, we can have control.
So Chinese say 保价啦.
Budget. So that's how you budget. Otherwise, you would commit to 0.65 kilo per ton is what you project or what you think, but in actual site condition, it may not be so.
Yeah, maybe just for sharing purposes, what do you encounter over this kind of EPC? What are challenges or maybe some obstacles?
There are, of course, many challenges. When we signed this EPC contract, we had as many as 12 meetings with the council.
Before commencing?
Yes. 12 meetings, and then initially when we presented to the council, of course they were very skeptical about the whole thing. I mean, I've got in the council members, some of them even are professional engineers. Right. The first question I tell you, Patrick, I think saving energy is very simple. I just have to raise the temperature, but by a few degrees, then you get savings. So I said, I told them, well, that is a very good question to ask, because by energy saving, we mean that the conditions must be better, at least the same or better, and then you save energy. That is application of engineering and technology to achieve energy saving. So at least they have a better understanding now, because I said it's making use of new technology. It's not even changing equipment. For example, the chiller plant, right? I think Derek, you know very well. If you're going to have just change a chiller for one chiller without upgrading or reconfiguring the whole system, you'll probably get 2 or 5% saving because of the more efficient equipment.
The equipment
but
more efficient.
If you look at the whole system, you can go up to 30-40%.
Yes.
So that is the difference between re-engineering and reconfiguring. So, of course, now it's proven beyond doubt that we have this type of saving. But initially, the difference was they do not understand and they won't believe that, by changing this plan, you can have so much saving. Right. So that's why the only way, the business case is to tell them that, look, I upfront the whole cost of the project, and then you pay me from the actual savings. That means no pain, no gain. So with this, it lends credibility.
True.
And to lend further credibility, but for this project, we didn't use that scheme. This is called the BRIEF scheme. BRIEF scheme is a government BCA initiative called the Building Retrofit Energy Efficiency Financing Scheme.
Oh, so under government.
Under government. Now, how this scheme comes about, because we also feedback to the government and say that most of them are very skeptical about this energy performance contract. Are you sure this? Because the moment we go to the bank to borrow like this sum of money to finance the project, the bank will ask you a very fundamental question. What happened? There's no savings.
Yeah, then after that,
so I said, when you borrow money to buy a house, very simple, they will tell you, what's the valuation? 60%. Good, I lend you 60%. And you can't repay, I'll sell your house. I get back the money. Safe. True. But for energy saving, I don't know what is chiller. So I joke with them and said, the problem is because there are not enough engineers in working the bank, you see. So I always tell them, look, what happened if there's a building structure? You mean you commission 2 weeks, the building collapse? Of course not, because it is engineering, it's calculated, it's proven. Right. But of course with the engineering factor of safety. So the next thing is, we actually spoke to the government BCA and says that, look, we need support from the local banks, UOB Bank, OCBC, DBS. They are very conservative banks. They won't lend.
They
because
make sure
they do not know how to finance energy performance contracts. So the government came in and says, look, if there is any a problem with the project that you can't recover, right? The government will share the risk. Now it's up to 60%.
So they are the guarantor.
The guarantor. Last time was 50, now 60%.
Oh, so they have increased.
They will increase to 60%. Then in other words, if the project doesn't perform, they will co-share the risk with the bank. So it lends credence to whole exercise, because this is part of the government's effort to green our buildings. Up to 80% of all the buildings by 2030.
2030, 80%.
This is a commitment by the government. So we are all stakeholders. So if they don't work hand in hand with us, then there is people like us. We go to the ground. There is nobody to support us. Then there's no credence. That's why this government, this scheme lends credence.
I see. So this is a BRIEF scheme.
This is a BRIEF scheme, and we did that for Bukit Timah Plaza.
For Bukit Timah Plaza.
Bukit Timah Plaza, we used the BRIEF scheme. Upper Serangoon also we used the BRIEF scheme. So under this BRIEF scheme, the condition is that the bank will extend the loan to whichever participating ESCO, but on the condition that the building will be at least green mark certified after it's completed.
Whatever level, or that a
whatever level, certified level.
Certified level.
Yeah. For example, Upper Serangoon, before you go and retrofit the building, you need a certain sum of money that you need to borrow from the bank. So you have to come up with some scoring, and then to satisfy BCA that after the retrofit, the building will be Green Mark certified. And because once you have that commitment, right, and the BCA officers will look through your calculation to see whether is it really true, is it achievable. If yes, they will give a letter of approval to the bank. And then the bank, in principle, yeah, is approval for the brief scheme. Then the bank will lend you the money to the company. But of course, the commercial terms will be between the bank and the company.
Interest are based on the bank.
The interest also will become between the bank and the company.
I see. I see.
But step one, you got to get it brief.
So brief is from the bank and based on the bank interest.
The brief is from the government to approve it, the scheme, and then the bank will negotiate with the company on the interest and all the terms and conditions. But it has to be brief before, let's say if the project fails, right? Then of course the government will co-share the risk.
I see.
If it is not under a brief scheme, right, then the government has nothing to do. If you fail, then the bank will have a lot of losses.
I see.
That's why the banks participate in this brief scheme.
Okay, so brief will involve the bank itself and also government agency.
Correct.
I see. So EPC is based on private.
Yes. Yes. And then for this particular project, we also gotten a grant for them under the GMIS EB.
Oh, GMIS EB.
It stands for Green Mark Incentive Scheme for Existing Building.
For existing building.
Yes. Now, previously the GMIS EB, there was $100 million fund for this. It has all been used up.
Oh.
In fact, the last one that's used up was by my company for People's Park Complex.
Okay, so
People's Park Complex is a very old building. I think you have been there. Wow, I tell you, that place is a very interesting place.
Opposite Chinatown, right?
It's at Chinatown, smack in the heart of Chinatown.
Okay.
The one that has got a very nice news recently about the people got to wait 1 hour to go up to the residential.
Oh, yeah.
All the 3 lifts too have been shut down by the BCA or something like that. So that building also we have actually turned into a green building. So this building, when we got it a green building, we were under this GMIS EB scheme. Today it's replaced by a GMIS EBP, which is a 50 million fund.
Oh, lesser.
Lesser, but it's an extension from GMIS EB. Now what's the difference? GMIS EB is more for non-residential existing building.
Non-residential.
Non-residential, mostly non-residential.
Right.
And then you existing buildings.
Must be existing building.
Must be existing building. And then of course you must have certain requirement in order to achieve this grant. You must be minimum gold. You must achieve BCA Green Mark gold. Then you can get up to 35% of the qualifying cost.
I see. So if you achieve higher, maybe Gold Plus, you get more.
There's Gold Plus, you get 40%.
Oh, 40%.
Platinum, 50%.
Oh, so 50% as
yes.
50%.
So this 35%, in order to achieve this, of course, they have a requirement on the chill water plant performance and in terms of point system to achieve the gold rating. Gold rating, I think, should be about 75%.
Oh,
75 points. About that.
75, yeah.
Okay, so in order to achieve this goal, you have to put in some green features. For example, like your water and all that. You must get at least a 9 point from the BOB to certify that at least you have some spring-loaded system or automatic dispensing for the water. Not open a faucet and then the water keep flowing. Then you can't get any points from BOB. Then we of course have to do some indoor air quality measurement of the building, because if the indoor air quality according to SS 554 or the NEA guidelines fail, then you do not qualify for the Green Mark.
So you have to do some additional.
But this additional stuff won't cost you more than $10,000 to $15,000. Generally, it's a very small amount that you have to add, because the building must look green, seriously, before you can be given that grant.
Sure.
And the grant, when I talk about 35% of the qualifying cost, this qualifying cost is not the project cost.
Not the project cost.
The project cost I mentioned was 2.2 million.
Right.
The qualifying cost is about $1.9 million.
I see. Then the rest?
The rest of them, you see, in a project cost, we are talking about buying the equipment, piping cost, equipment cost, consultancy, engineering costs. But there are also other costs, related costs like insurances, legal costs. Now those cannot come into the green equation.
Oh, so that is separate.
Those are taken out. That's why the qualifying cost is a high percentage, like 80 to 90% of the implementation cost. And you are, once you hit, like for example, gold, then you get 35% of this qualifying cost. And it's paid in 3 tranches to the
they don't
owner.
pay you.
They don't pay you one shot, no.
So
when you complete the project, after about 6 months or so, they will come and do an inspection. Then they give a very small percentage, which is the first tranche. Then probably a year later, you get the second tranche, followed by another half or a year later, you get the third tranche.
I see.
So they do not pay the grant to you upfront. You must complete the whole project, prove to them that you are actually meeting those targets. They're satisfied that you satisfy all the green features, meet the green mark goal criteria.
Then
they will disburse you in 3
see,
tranches. So they got about $800,000.
Okay.
So effectively, they paid only $1.4 million for the project.
Which was
Yeah.
good.
So this is a very inspiring project for the rest.
Right. So there seems like there are so many incentive and so many model like Brief, GSP, Green Mark, EBP, and all these. Maybe you can see what's the difference between, maybe you can quote some of them. What's the difference between the private and the government kind of?
Government project is straightforward because they are government projects, so of course they are not entitled to this Green Mark incentive scheme.
So if you're a government agency, you're not
Not
entitled
at all. No.
At all.
No. But for government projects, in fact, by 2020, most of the government buildings, the government is committed for them to be Gold Plus certified by 2020. So I think in the next, today is 2017. I think it's over. They don't have the time to catch up, but I think there will be a lot of public tenders coming out to quickly convert them to be Green Mark Gold Plus. But I think this will spill into the 2020s already. And I think there's tremendous potential for buildings with Green Mark certified, because we still have a very big stock of building that needs to be green, and also, mind you, this building was converted to a Green Mark Gold building in 2010.
2010.
Yeah, that's 7 years ago already. Yeah, that's already 7 years.
So you're still doing.
So very soon this the chiller plant is going to be aged, and then you have another round. So I think this green sustainability business is here to stay, okay. Although of course
Donald Trump said no.
Donald Trump said no, but the thing is, I think there's a tremendous potential, and we are also going into various renewables. Some of our own. We are targeting a lot of buildings to actually put in solar panels and put in new technologies. Sure. In fact, you look at this building, we already got 800,000 grant. It's already a Green Mark Gold, but we have not even got time to replace the lighting. So the next, we have already called a tender. We're replacing all the lighting with LED lighting.
So
but of course,
LED lighting.
All will be LED lighting. But it's quite challenging because we are going to increase the illuminance to brighten up the place, so as to improve the tenancy. Because currently the tenancy here is pretty quiet.
Okay.
So we are going to upgrade other facilities.
So there's a new facelift here.
Big escalators, lift escalators.
Okay. Maybe just in conclusion, maybe you can share a little bit. What do you think in the landscape in Singapore in terms of energy, green kind of thing? What do you think maybe in the next 5 years or 10 years? Because I mean, the next generation will come in, the next wave. So what do you envisage, and what are the opportunity really for them?
You see, personally, I'm very passionate towards sustainability, environment sustainability, and green engineering, which is why maybe I got Green Engineer of the Year 2014. So personally, I'm really passionate about it. We have to work very hard, of course, to make this earth sustainable. This for future generations.
Right.
Because you see, all the climate change, warming, disasters, all caused by climate change, and we can only do our small part. Because Singapore's contribution, I mean, admittedly, we are very small compared to the rest of the world, but of course we can do our part. And these green collar jobs are here to stay, because one of the way to be sustainable in terms of, in fact, I said the business case for energy performance contracting is actually saving the business cost of the owners. Right. And that's why people really will go for to do it. At the same time, you're not only saving energy, saving resources, you're also paving the road for our future generations, so that they will not be deprived of energy, and you got to minimize the disasters from climate change. So green jobs, of course, will be gaining momentum. That's why the PCA is very bent on training more green professionals, so that they can actually fill the jobs, the gaps. For example, in the energy sectors, those with 15 gigawatt hour and above, you need to have people with Singapore Energy Managers qualified,
What
to
the
be on the payroll, the
ECA,
SCM.
right? SCM, right?
So now we have about 400 odd, but there are a lot of 200 odd industries
I see.
require SCMs.
Right.
And all the architects and engineers, if they want to be on panel 1 or 2 to tender for government jobs, they have to pass, at least 2 of them must have the GMP, Green Mark Professional, Green Mark Facilities Professional qualifications. So Green Mark certification is here to stay, okay? And of course, if you talk about energy prices, may be low now, but in my opinion, probably this is only an interim, seasonal phenomena.
Right.
Eventually, of course,
resources
will be depleted, and the only thing we can do as small city-state like us is to conserve,
right,
and of course get the maximum mileage of what we have. That's why we have to think of alternative renewable energy as well as conserve what we are using. And the best way is through energy management and using sustainability measures. But to add on a final point, you see, a green building is not just about conservation. It's also about how to be environmental friendly for its users. For example, indoor air quality. If you really go into the building fabric, whatever is happening in the building, you see a lot of people are suffering from sick building syndrome, etc., etc. It's because of the air, that we breathe in. And most of the air conditioning buildings, we are using air handling unit, fan coil unit, which is all recirculated. Yeah. So we can't see with our naked eyes what are all the pathogens, what are all the dust, and all these are affecting our well-being. So indoor air quality, which is indoor environmental quality, is a very important pillar of this green building requirement. So with this requirement, we will have to make sure that none of us are working or living in an environment which is very detrimental to our health, because a lot of these health issues can come 10 years later.
Sure.
Yeah. For example, you go and take in the formaldehyde, pathogens, all the bacteria that's all hiding around. So this is something that is a very area that will be gaining a lot of importance in air quality. Yeah.
Right.
So I think for your students, there's tremendous potential, whether in Singapore or any part in the world, in the region. There will be a big demand for these green collar workers and professionals. Yeah.
Great. So really appreciate Patrick for sharing his experience, and of course to highlight to us what are the transformation in green and energy landscape in Singapore. So once again, thank you very much.
Thank you very much, Derek. Yeah.
And maybe the next time we have another one.
Certainly. Thank you very much for your attention. Thank you very much.
Right.
Right.